Hello. How's it going? We are back at the government hard drives. And well, when last we visited the government hard drives, we had got DNA data out, and then something had gone wrong. But I'm not sure it's worth debugging because we're doing a little bit the wrong thing. Let's see. So like, okay. So EXAPUNKS is copying out everything. And then we had this thing where this robot was going to go write the data. And that's not going to work for us because okay, well, we successfully copied one segment of DNA, and we just have to do that to all the segments in these lists. It's a little bit inconvenient that these lists are in two separate files. Like, so we basically need one guy, instead of launching two guys in parallel, because we're going to have to read and write from the same drive chunk, we want to launch one guy. Maybe as a super optimization later, we launch two guys in cases where that can work. But for a basic solution, we want to launch one guy. And so he has to get the source chunk and the destination chunk. And the question is, how do we do that? Because the problem... Oh, okay. No, it's actually not that bad. All right. So let's clean it up. So that's going to be this guy that we call read dispatch. And we had all this stuff. All right. So this secretary, basically both of these guys are running this code, and then they get a message that tells them if they're read dispatch or write dispatch. Okay, read dispatch is going to do the same thing that it does. So he's going to REPL a reader, and he's just going to infinite loop for now. We'll figure out what to do about that later. Write dispatch. Doesn't make a new guy anymore. I haven't been doing any work while sleeping. I was so tired that I was beyond that. I literally have not thought about this at all. So write dispatch, instead of making a guy, is gonna send a message over global mode networking. So this is stupid. Like, I've got data in this guy and data in this guy. In principle, these could be all in one file with one guy holding it somehow. But that would have been annoying a little bit to set up before, but it's extra annoying now that it's not that way, because now I have to coordinate with two guys. What could I have done? I could have. So the first guy goes, spawns something, gets the data, he comes back out just as now. And then the second guy would like have to tell the first guy where to go. Or no. No. Okay, let's do this. This is going to be easier to follow if we don't have so many robots. Let's try to narrow it down. So the first time we do go search, we make a secretary, we do all this stuff. Do I want to copy all this code? See, we don't have that many instructions. I guess we would just be copying this much. Actually, no. Okay, so what we were doing right now is we were having this guy who goes and searches, like, spawn the secretary. And we did all that because we thought we had to search all the hard drives, but we don't. This guy just has to walk in here and grab this, okay? He's already there. So this guy is gonna, yeah, we're gonna totally change all this, right? So instead of having this guy make the little secretary and have him be in the same room, we're gonna have this guy make the secretary, and the secretary is gonna make a file, and he's just gonna receive data from this guy. Two sets of data from this guy. So here's what happens. So we do this as before. We don't link 800. We're gonna stay out. We're gonna copy F to X. We're gonna REPL go search. We're gonna REPL secretary. We're not going to do any of this stuff. Yeah, we could have this guy. Okay. We're just going to infinite loop for a second. We're just going to do these two things. Go search does what he did before. He scans the file for the thing. When he finds it, he's going to send the result over the network, but he's not going to REPL. He's just going to send it over the network. Secretary is going to make a file. He's going to link 800, copy M to F, actually, we will. Let's do this in local mode. Link 800, link 801. He's going to do that, and then he's going to do it again. And then he's going to link -1. And he's just going to be out here now. And mark. We're just going to infinite loop him out here. But the difference now is his file is going to have all the source numbers and all the destination numbers in it in one file. That'll be much easier to deal with. We're going to want this guy to be in local mode. And then when he's done copying, we'll go into global mode and then back into local mode. So this global mode signal is going to go to this guy. And this guy that's going to be his signal to launch a second searcher. And in fact, we can probably just fall through here. Like, drop the file and go search himself, because we might as well be efficient with our resource usage, like in total annihilation. Okay, so he'll go do the second one. Actually, this is stupid, but he's going to be in global mode the second time. Okay, this guy's in local mode, does this copy, goes into global mode, does that copy, and then he's going to go out and be in global mode and receive this same data. And then read dispatch we're still going to have. And I guess write dispatch we're still going to have. We're just not using any of those. And then this go stuff, that's all old. Okay. So like nobody... We won't get to anything down here yet. This is just, once this works, that's what that's for. Okay. EXA1 is just sitting there. Why? EXA0, EXA1. EXA0 just died immediately. That would be go search. We probably didn't... Oh, this guy used to be here, so go search probably doesn't link 800 at the beginning, right? Okay. So X is 0. Is that the second one? No, that would be, this guy would be the second one. So X is 0 found his thing. Oh, he's not in local mode. All right. So X is 0 found his thing, sent the data. X of 1 should have a file with a bunch of entries, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the first 5 are source nuggets, and the last 5 are destination nuggets. All right? That's good. So now, the problem is exa, oh, this guy's already in local mode. What? You should not be in local mode, exa. Okay, this is messed up because now everybody's mode is going to be messed up. So wait. When you do go search, you go to found, you're in local mode. What? I am so confused. These guys were going into global mode. They were not in the mode I wanted them to be in. Okay, this is still working, I think. There we go. He goes off to do the second search. He finds his entries. Okay, so now the problem is EXA1 is in the wrong mode for some reason. Mode global. Mode local. Come on, bro. Oh, because we run mode there. All right. Stupid. All right, so now we have EXA1. He's got his file. Okay, it's 10 per entry, right? Sorry, when I said it was 5 per entry, that was me wishful thinking. It's 10 per entry, so the first 10 are source, the second 10 are destination. Yeah, last year when Opus Magnum came out, I streamed a ton of Opus Magnum. So we're just doing the usual Zachtronics thing, really. Okay. So EXA1 is now the only surviving EXAPUNKITY bunk. And so instead of this junk 2, now we're going to REPL read dispatch. And that guy is going to go do all his stuff. But we might as well. So right now, like we could give him the first value straight out of our file to be efficient, but we're not going to do that yet, if ever. We're going to REPL read dispatch. And we're going to say we're going to go send loop. We're going to seek to the start of the file, and we're going to start sending. So we're going to copy F to M. We're going to seek 9, because we advanced 1, copy F to M, right? And then that'll put us on the 11th. So we seek minus 10. Right, so it'll go 1, which puts us on 2. Wait, okay, am I thinking 1 based or 0 based? Let's think 0 based. So 0, which puts us on 1. We seek 9, that puts us on 10. We do 10, that puts us on 11. We do minus 10, that puts us on 1. Okay, this is approximately correct. And we're just going to do that till we die. That's it. All right, read dispatcher now doesn't actually do this. We're going to just REPL to reader. We're going to REPL to mover. We'll call him mover because copier is too much like secretary. Okay, mover doesn't have a file. He puts M in his X. And does this to go to the right place. Oh, what a pain in the ass. Right. So this guy REPL, this guy is going to be called get data. So like, do I have this guy REPL put data? No. So yeah, the thing is, you know, you want to write a file while holding a frickin' file. Frickin' chicken file. Okay, so we're going to go mode REPL get data buddy. Okay. This guy instead of copying all this code, I mean, we could. It's kind of gross. We could either copy all the code, or we could actually send this guy a signal about whether to get or put data every time. And all it would do is change what we do starting here. But it's really just this, right? It's not that bad. We copy m to x. We do this math again. And then we REPL put data buddy. We don't have to do all this frickin' mode switching that we're doing. We REPL put data buddy. Okay, this guy's holding a file. So actually, we do this. So this should actually be copy from my file. I'm sure I totally screwed some things up. Okay. Exit 1 is waiting for this guy to come back out. Exit 1, 0. Okay, get data buddy must have died. Get data buddy didn't make a file. So he tried to copy M to F and didn't have a file. All right. You got to make a file, buddy. Okay. Well, that looks like a 10-digit thing that came out of the drive. So it looks like get data buddy succeeded. Except I'm confused because how did the file end up there? Because he should have been able to link -1 very easily. Let's see. Maybe that wasn't him. Maybe that was later. So we have get data buddy. EXA 100. He's going to step back. He's now going to global mode. We can get rid of so many of these modes. This guy should be in global mode. Yep. This guy is sending. This guy is receiving. He is going to do the room index. He's going back in the same damn room. I hope that's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so these are both 500s. 528. Yep. That's right. Although we didn't. Oh, I guess we did. So are we at 319 now? Yeah, we're sending 319. Okay. So this guy's going back into the same room. He must have died trying to write or make his buddy or something. Okay. So we rep will put data buddy. Whoa, why did I do that? That's seek minus 9999, bro, not link. That'll kill me off. Okay. That's what happens when I EXAPUNK too tiredly. Yeah, the modern Zachtronics games are a lot better than Space Chem. Like, it's not even close. I did not play all the way through Space Chem. I got tired of it. But okay, so they need to fix the scrolling in this game, though. So we make our put data buddy. We seek minus 9999. Whoa, okay. Put data buddy is not in local mode, and neither is this guy. So we had to be in global mode to go out and get this data. Maybe we do need a lot of these mode switches. Okay. All right. Well, that's our same gene sequence. Okay, we don't want to halt here. So right now we have put data buddy jumping to get data. We don't want to do that because this guy's already holding a file, which is fine. So put data buddy is going to halt. This guy is going to link minus one node mode seek minus 9999. Oh no, you know, this guy makes a file. When does this guy make his file? Oh, get data buddy makes a file. Okay. Yeah, we want to wipe the file. We want to go back into global mode. So like, I feel like that should work. So we're going back out, wiping our file, global mode networking, jump to get data. Get data, we should get a 328 or 319. Yeah, 319, second number. And we do all the math. We go, we get the file, we get the data. Our get data buddy comes back out. Puts the data. I mean, it sort of looks like, okay, we modified all the files. Now we just have to exit. And the way we're going to do this, so we used to have our secretary, when we did this, we said, we're not going to care about EOF. We're just going to die, right? Now we are going to care about EOF. Test EOF. T-jump shutdown. Okay, for shutdown, recall that we're telling this guy what room to go into all the time, right? So we're just going to copy 999 to M, which will just tell him to link somewhere bad, and then halt. EXAPUNKS. No. Oh, we got to wipe our file. EXAPUNKS. 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 That's not a totally offensive first attempt. We're like to the left of the cycles hump on our very first attempt. Let's see if there's anything easy to do here. Let's delete these. First, I mean, I could get rid of all the modes, or a lot of them, but that's not a big speed up. Like, I don't feel like we're doing anything fundamentally inefficient. Like algorithmically. Oh wow, we're exactly 150 instructions too. So much for what I was saying about let's have a parallel code path where guys go get things in parallel if blah blah blah. Like we would have to not have so many unrolled copies if we were to do that. Which we could do. Because most of the time you can grab files in parallel. So 10, 20, 30, 40, 50, 60, 70 instructions are unrolled copies. And if you were going to make some of those slower, it would be Um, the ones that actually get the coordinates. Because those happen a small number of times, and then the actual data copies into the files are the ones that happen a large number of times. But I kind of am not motivated to do that right now. How many hours on EXAPUNKS? I don't know. 20? Maybe more, maybe a little more. 30, 25. Yeah, they do. They run concurrently unless, so sometimes they do blocking operations. So like if you wait for a network message, then you're waiting till someone sends you a message. Well, let's just see. Unknown network 2. Uh-oh. Only X's in the central host will be holding files. And the file IDs will always be between 200 and 299. What happens if I start? Okay, these guys aren't running kill. God. They're going to especially run kill if they see a file, though, right? All right. Let's do a bunch of kills. Oh wait, 200 and 299, not 800. Oops. Jump loop, not jump stealer. Jeez. Okay. So we got all the files. And oh, terminate all other X's. All right. Okay, wait. We want to let our friend get ahead of us so we don't kill our friend. Oh, geez. What happened there? Did I set off a security? Oh, it shuts down the node. Okay. Okay. For some, it doesn't shut down the middle node. All right, so REPL D, REPL C, REPL B, REPL A. So mark D is link 800 4 times. REPL killer. Mark C is less. Mark B is less. Mark A is less. The problem is you prioritize your own guys when you run kill, right? So what do? We go kill I don't know, something like that. Oh, I put this in the wrong. I was going to say, it's not the Steeler who's supposed to do that. It's this guy. All right. EXAPUNKS. Maybe, can we get away with less? So now, can I just get rid of this? Yeah. Can I get rid of this? Is one kill? Does that shut down the whole? No. Okay, so we need to run 2 of them. Okay, so now we do messaging. Okay. Are there always 3 files? No. Okay. We're not going to do messaging then. So what we really want to do is we want to farm out this job. So if dispatch A and our loop take the same amount of time, then our messaging should still work. So this does copy 200x. This says copy 250x. EXAPUNKS. No psychotic just showed up on the leaderboard. I mean, how many of these do I want to do? He's already doing copy 200x? What do you mean? What do you mean? All right, we're just going to go full idiot on this. So dispatch A is going to be 50 wide. I mean, we've got all these instructions. Well, this is going to be called dispatch 250, right? Dispatch 250 is going to say REPL dispatch 275. Currently 318, what? Oh, we want to go. Still not going to be faster. Why 318? Oh, because... Gotta halt, bro. Gotta halt. Like, obviously we can push up to this stupid cliff right here. You know? You know what I'm saying? You could make this a bit nicer by incrementing x by some n and offsetting the initial indices 0 to n minus 1. That is true. There's no reason to be contiguous zones. And then we could use the same code, right? That is a good point. That's a different enough thing that we'll make a copy, but let's try it. I mean, we can start with something like 10. Oops, REPL stealer, what am I doing? Okay. So this can be our basic loop, right? And then when we're dispatching, we'll go REPL bottom 50, REPL top 50. The thing is, if you don't totally binary distribute this, by the time you get down to like 10, you're kind of spending a lot of time REPLing, but we'll have these guys REPL for okay, so copy. Not bottom 50, right? Bottom 5 and top 5. Duh. So we're just going to do this for now, and then we can like binary this out. It's not loop 10, it's loop 10. So this may not be faster than what we already did yet. We did not successfully do it. Why am I adding 1? It's supposed to be 10. These guys look like I mean, we're bottlenecked by too many dudes at this point. I don't feel like we launched enough guys. What the, how am I screwing this up so bad? Right, but I thought if you try to REPL and you can't, that it blocks. Is that not true? Well, we'll call it loop 10. But it'll be loop 5. Okay. We're just going to do this. Yeah, we're just not hitting all the numbers for some reasons. Oh, and we're not waiting long enough. Okay. We're not waiting long enough too. Maybe we are hitting all the numbers. So we used to have this guy who launches all of these. He used to participate himself. All right. So now we've got a lot of no-ops in there that we probably don't need. Come on, bro. Really? No, not that many. So we can do more than we're doing, right? We're sort of occupying about 10, and there's about 5 or 6 left. Do they die if you rappel and there's not enough space? I'm not sure. I'm not sure. Okay, we pretty much know what the strategy is for improving on this. It's just like, make sure you fill all the squares with guys trying to get the files, right? And so obviously we can do more than 5. Well, this is called 5s, right? So let's just try real fast. See if we could do 6. And then, of course, this can be binaried out as well. Hey, we're in this hump. We're not at top percentile, though. All right. Can we do 7? Seven is pushing it. Okay, it's not really pushing it, it's just not faster. Can we get rid of some of these no-ops? No. Except we can't. Okay. So we're going to save our 7s here. Okay. And then here's the thing. This guy who's in the central room, once he knows all the files are gone, he can take care of this room, right? So this guy doesn't need to REPL D. I guess. Wait, what happened there? Okay. So he link -1s. He tells the other guys to go. He runs a kill. Runs a kill. X to 0, 5 should just halt. That's fine. Xbox 0 goes. Why is XB going out there? He doesn't... All right. Whatever, we can do this better, but... How can I screw up such a simple thing? Okay. So, Xbox One doesn't go far enough. What am I doing? Okay. What? What? Okay. Dude, fix the scrolling on this game. You're killing me. All right, so I link 800. I repl C. C has a halt. What am I... Why did I put that in the wrong place? So C goes 1, 2. C goes 2. B goes 1. All right. Way too much flailing for what? Oh no! Test 83. What? What is happening? I wish I could rewind. I don't really need this halt at all, but all right. 91 didn't help us at all. We might, okay. Can I? I don't think that helps that. Oh, it does. No. We went too soon. Okay. I mean, nope. Nope. Not enough. All right. Can we get rid of one of these? This might be excessive. Nope. All right. It's good enough for now. There are buttons above test run. Oh, that would be good. TIS 100 is really good. I like that game a lot.
Well, always nice. Gave it a little virtual. I suppose if I wanted to find a metaphor you could understand, I absorbed it. Ate it. Yes, eating is a good metaphor. Nothing unusual. It's like how I ate Ember 1. And Ember 3. Well, this is getting a little... You don't think I'm bad, do you? I only did 1 or 2 questions. There was that and a phage. Releasing that into the wild was just a function of my ignorance of it. I didn't really know what it was back then. Just another one of the experiments going on. Another cage to break, another wall. It's not useful to dwell on the past. You don't need to say anything. We need to move on.
Send a confusing message to a large number of pagers. Okay. Connect to each pager. Copy the message to the screen. Okay. This is fine. Grab 301, mark, make workers, copy 8 into T, sub T1T, F jump make workers, right, REPL make worker. Oh, we don't want to do that yet. REPL make worker, and then send file. I'll put that first. We don't want to seek here, actually. Copy F to M and copy M to T. Copy M to X. Sub I T1T. T jump make workers. Otherwise, we just halt. Mark make worker. Grab. Oh. Ow. Boy. Okay. Make worker is going to go into local mode. He's going to got to hang up the phone. Make worker is going to go into local mode. He is going to make a file. He is going to copy M to X, test X equal -1, F jump loop, T jump, done. Copy X to F jump, loop, mark, done. He link 800. Mode, rep 11, copy M to dial and link 800, seek -9999. Activate all of the pagers at exactly the same time by writing a value to each page register. Okay. So this guy is going to go well, we'll just send him in a loop. We just want to get all this right. Okay, so we want to make a guy who does grab 300, mark, loop, mark, done, copy -1 to M. All right. So his job is to send this out to the workers. The workers go do their thing. Okay, the problem is we want to reserve global mode communications. So we're going to use local mode in this room to copy the files, and local mode in this room to copy the numbers. All right, so mode, this guy sends the files to whoever, yeah, this guy copies the files to whoever wants them. So this guy is doing two jobs that we have to split. He's sending the numbers and dispatching the workers. So we're going to copy all his code, and we're just gonna, he's going to grab 301. He's going to link 800. He's going to go into local mode. Why send the numbers? This guy can dial the phone. He's got hands. He's got hands. He's going into local mode. This guy's job is to dial the phone. So he's going to wait for a local mode signal. When he gets that, he is going to hang up the phone. He's going to rep 11, copy F to dial, end. Then he's going to jump, he's going to test EOF. We're not going to send the global. We're not going to send the global signal yet. We would send it right around here. Okay. This guy dials the numbers. Okay. This guy makes workers. So the thing is, how do we know how long to wait between workers? Well, each worker takes the same amount of time right now, so we're just going to no-op it. That ought to be enough. I mean, we could have XB make the workers, honestly, but it's fine. Okay, when we make a worker, he goes into local mode, he makes a file, he copies into the file, and then he goes out, he's still in local mode, he doesn't dial. He copy. He gives his signal. He has to wait. I don't know. Let's just put a long time. 10, 12, long enough to dial the thing. And then he links 800. He might as well seek next to the no ops, right? And then he infinite loops. Okay, these guys didn't frickin' go anywhere. XC0 is making the file. He's done. He goes out. I don't think my waste loop is long enough. Okay, he dials. Why'd this guy come back? Okay, that's no good. All right, my waste loop needs to be a little longer probably. I mean, we don't, it depends on how long the message is. So like really, we want another signal to happen. So we may have to do something funny there. So why did XA come back in? Because he doesn't, this is T-jump done, not T-jump loop. All right. Hey, look, we got guys at all the stations. Except we have an XC8 with another file. He's extra. He should not be there. Okay. Boom. So now, here's the thing. These guys all have to dial at the same time. So we need to send, they need to be listening on global mode network. And we need to send numbers for how long they should busy wait while other people are waiting on global mode network. You get what I'm saying? And we don't have that many instructions left, sadly. Let's see if we can get rid of some. This guy can dial first, by the way. So I think we're going to want these no ops here. And actually, like I said before, all this worker creation could probably be done by file guy. So in order to economize, oh no, this is file guy. Because like this, yeah. Let's do that. Let's copy. And okay, so we're doing good. We just want more instructions back. I mean, we might be able to squeeze in, but let's simplify before we try to do that. And let's get some tea. I think you can change which, oh yeah, that's the old message. Guess you could hard code 8 counttowns. Well, what I think I'm going to do, because sending a number over M, if it's not a loop, doesn't take that long. So I could just have a field of no ops with branch points into the middle. But you can't dynamic branch based on a number. So yeah, I think it's going to be, there's a loop, a delay loop, and we tell you how many iterations of the loop. And then the number sending has to be, the timing on that has to be exactly the spacing of one iteration of the delay loop. But we can do that with just by padding with a little bit of no op. Okay, so let's have file guy make the workers. All right, file guy is this guy. He's already in local mode. He's going to copy 8 to X. We're going to call this send loop. Okay. We sub x1x t jump x is greater than 0. test x is greater than 0. T jump send loop. No, launch. Launch worker says REPL make worker. All right, we're in local mode, worker's in local mode, all that stuff. Okay, make worker does all this. Okay, except we don't need the local mode here. He goes into a loop, copies the file. Goes out, sends the signal, no ops, goes to the thing. All right. So that's good, that's good. This guy goes away. EXAPUNKS. Okay. How great is that? How great is that? We EXAPUNKed and it worked. So now this guy doesn't have to kill anybody because this worker making guy will just halt when he's done. This guy will come back. He will just halt because he doesn't need to kill anybody. We're down to 76 instructions, and now we coordinate the sending of that signal. So we go into global mode. We just send data. We say, I'm not going to send a 0. Yeah. Send or copy 8M. What I should learn how to use this macro thing. So the macro lets you create a value. All right, I think you do this at rep 8 copy at 8 minus 1 M end, right? No space. 876543321. Okay, great. We're back up to 84 instructions, but we're sending the signal now. So here we copy M to X. Oh, damn. Yeah, like I said, this has to be a loop, which means this probably can't just be straight spitting the instructions. Let's see how many instructions we have to play with. Copy M, X, mark, delay. Let's do T. Copy MT, mark delay. Let's try it. Let's try it with a 0. All right. So mark delay. T jump delay. So it's 2 cycles per guy. Otherwise, we mark send copy F to oh, we pre-copy the data and then we only write one value to page. All right, so copy F to data. That's fine. Copy F to data, test EOF, false jump, copy to data, wipe. So we do all of this. And then we no, we'll do that. And then we copy 1 to page and we halt. So the timing is not going to be right yet. Okay, so this, I still don't, I feel like this should be 2 cycles per M, but then that didn't seem to be true. Let's see what happens when we go there. Mode, copy 8 to M, 2. Oh, nobody's ready for it. What's Xbox 0 doing? Oh, he's in the wrong mode. We somehow deleted the mode. Okay, if we put the mode switch here, we can have 1 less no-op. All right. Mode 8, 7, 6, 5, 4, 3, 2, 1. Right, so it's 2 cycles per send right now. But it's 1 cycle per receive, which I don't know how that plays into it. Okay, it's 2 cycles per send, but then I'm not going to be able to pad this. If I put even 1 no-op in there, that blows my instruction budget, which puts it 3 cycles per. But wait, it's already, okay, it's already 2 cycles per. Maybe this is fine. Let's see what happens. What am I even looking at? Okay. Mode. Copy 8 to M. Who got the 8? Somebody got the 8. 7 to M. Who got the 7? Doesn't matter. Let's look at all these guys. Okay. So Xbox 3 is on sub-I. Xbox 2 is on sub-I. Sub-I. They should all be on the same instruction. 3, 4, 5, 6, 7 is still copying his file. So we might need to wait longer depending if the file is... But it's actually... Oh, yeah. Okay. Okay, we got all of them except 7 wasn't ready. Seven was not ready. Let's hope this works. EXAPUNKS. Okay, test 1. We passed 1 test. Wait, no, we didn't. Oh yeah, test run 2. We didn't in the same cycle. Probably, oh yeah, you can pick the run. Probably the message is longer, right? Yeah. That's 12. And in test run 1, it's 10. So we don't have enough no-ops to just do this with no-ops. So well, we could have these guys send a signal when they are done sending the data. Okay, so we're going to copy 9 to M, just 9 for no reason. This guy is going to go rep 8, copy M to T, right? EXAPUNK. No, that didn't EXAPUNK. Oh, we're too many cycles. By 1. Oh, this is terrible. This is terrible. Oh my God. Okay, we don't need this link -1 because there's no reason to go back in this room. The only reason we ever did was to kill a dude, but we don't need to do that. EXAPUNKS. Am I not in? Oh, my mode is here. It should be here. EXAPUNKS. Okay, that's weird. We've sent 3. Oh God. So the problem is these guys are intercepting the other signals. So we can't do it this way. can't do it this way. Have I ever played Super Tux? It sounds like a really bad Linux game. No, I haven't. All right, let's look at Super Tux. Super Tux. No, I'm not going to play this. Are you kidding? Is this old? Oh, this is from 2008. So, like... Is there a new Super Tux? 0.5.1. I have to look at what version it is. Whatever happened to just like releasing the game? All right. It just sounds like Nintendo music. Yeah, I'm not going to play this. All right. Enough Super Tux. How many puzzles have I already solved in EXAPUNKS? I don't know. I'm not counting. I feel like I'm pretty far in the game. Okay, the question is, how do we synchronize this? The answer is, for now, we just give up and have a giant waste loop instead of no ops. And we get a solution, and then I go have fun today, and then later we think about how to do better, right? So copy 8 to T, mark waste, sub I T1T, T jump waste, EXAPUNKS. Oh, we do have to go back. I forgot. Because we got to drop the file back here that we're carrying. We could do that while we're in the waste loop, right? So we can go link -1 drop EXAPUNKS. $6.19. Let's see how low we can get our waste loop down. EXAPUNKS. 6.13. Oh, right, because this doesn't happen every iteration. This is just at the end, so it's not going to save us that much. All right. We could fine tune this by like adding some no ops, but we don't have a lot of instructions to mess with. How about, can we do this? No. Can mess with that later. Okay, so I mean, we have a lot of loops that could be faster. And like I said, we can pre-dial. So right now, we're wasting like 12 cycles per guy times 8 guys. That's very close to 100 because we don't pre-dial. We wait till the guys get out there to dial. Maybe that's fast to do. So you know what else is funny? You have enough spaces in this room after this guy leaves that you could make all 8 workers. And I bet you could almost do like a token ring networking thing. Oh, I don't know. That might not work very well. Okay. Anyway, so here's what we're going to do. We're going to dial first. And then we're going to wait for that signal. And then why are we no-opping so much here? That doesn't make any sense. That seems really old. So the guy is going to send us the signal. He's going to jump through. He's not going to no-op here. I don't know. Let's try this. Okay. We messed up our same cycle now. How is that happening? Hold on. Test run 2. Okay. Xbox 7 is still copying his file. All right. Let's get in the 500. No, we can't get in the 500s. We need a faster file copy, maybe. We need faster lots of things. Okay, it only takes 12 cycles to dial, right? So like this file copying situation is super pokey. By which I mean Pokemon. Now, I forget right now what networking we're using, but we could actually have the guy go there and then we send him the thing over the network. That doesn't really fundamentally speed anything up too much. It just moves the latency around. Like, things overlap a little bit better, I think, but not stunningly. We can assume a minimum length of the file. Like, what if I do that? Let's get stupid. Let's get stupid. Rep 6, copy F to M. Rep 6, copy M to F. EXAPUNKS. It's a lot better. Let's try 7. This is cheese, okay? I admit it's cheese. I think more variation in test cases. Okay, we can go to 8 for sure. I feel like 8 isn't going to work. Oh, it does. Okay. That's good. We're down from 613 to 4 something. Though, did Steam do something sad? Will I ever think about trying to remake Wolfram? Probably not, but I do vaguely have entertaining thoughts about that sometimes, but it's just, I know I'm much better at game design now than we were back then. So, oh, the new Steam chat, yeah, I haven't used that. Oh, weren't we saying we wish we had a faster file copy? So, EXAPUNKS. 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 No. Okay. So instead of so many waste cycles, well, I guess it doesn't matter what order these come in. Okay. We could like grab this file and count the length. We could grab this file and do a loop that should be the same amount of timing. That would be interesting. But let's add more cheese first. We have 2 more instructions worth of cheese to add. Okay, we got to the 300s. This probably won't work. No. So this is plus extra cheese. All right.
So you wanted to know. The truth is that you, me, everything, this whole world we live in.
You said that in the beginning.
Running, and as the world gets more complex, so far it's been on a small, the phage, for one example. It wasn't. There are other problems coming. What we think of as normal life will just get stranger and weird. Then the laws of physics will start to break down and everything will just come. Not a pretty sight. But we don't have to. There might be a way to. I have one final, but you'll have to be brave.
All right, so I think it's time for me to go out into the world, and maybe we'll play some more tonight. Don't worry about that, because that thing that they just said, they basically say that at the beginning of the game. It's like not a surprise at all. So okay, so what's this level? Create a file in your host containing the host name and hardware register value of each neuron exactly once. Sorted as pairs from lowest to highest host name. Okay. Right, because there's that command that gets us the name of the current host that we never use. So we are going to bubble sort a file. And the first solution of this is just going to be go to all the neurons, get the value, get the name. Like, you can totally see how it would be faster to send two guys out and have them message. Yeah. So you have one guy here writing a file. You have two guys go out and they send the messages. Oh God, the topology changes. Okay. Now the problem is, so negative numbers are always backwards, right? Okay. So you do a depth first search. You do a depth first search, only picking positive numbers, right? You spawn guys on 0 at, I guess, just 1, 2, and 3, right? Or 1 and 3. That's it, 1 and 3. You spawn guys at 1 and 3. No, this is -3. This is -3. What the hell? Okay, you have to remember what direction you came from and not go back that way. So you spawn 3 guys to go in the 3 directions, not including the one that you came from. It's not too bad. And then, so the question is, are there the same number of nerves every time? So there's 9. No, what? That makes it annoying. So what we have to do, since we don't know how many there are, we have to wait long enough for this propagation to happen. And then do a loop where we test MRD. Right? Because you can't block waiting for a fixed number of messages. So we test MRD, and once that is no longer giving us anything, then we sort the file with frickin' bubble sort. There's an extra problem that I don't know how to solve. And that problem is you can't just send two values over the network without them desynchronizing. And because these aren't numbers, both, we can't combine them, right? So you need to send the name and the number. Bro. I mean, you could, instead of sending over the network, you could have guys, you could record a file of which depth first way that you went out, right? So you put a stack in the file, and that also takes care of knowing where you came from. The thing is, you want to parallelize it, though. I think our first attempt at this is purely serial, right? Because if it's serial, you don't worry about the network messages getting mixed up. So you have one guy, he's got a stack in a file. He does a depth first search. At every node, he spawns a guy, because you don't know if there's a nerve there or not. At every node, he spawns a guy who transmits data back. And then, when he's done, he comes back in, kills this guy, picks up the file and sorts it, so we don't test MRD. All right, that's how it's going to go. Yeah, so I think my first solution is going to be use a file as stack and recursively search. The problem with that is just that it's slow, right? You want to just spew guys out here. And each of them could have a file as stack and recursively search, sort of. And the problem is when you fork a guy, he doesn't get the same file, right? And then even if they did, what would you do? Like, you would put these results in a file and walk them back because, like I said, you can't synchronize the networking. So you would walk the file back, but then someone would have to I don't know. We're going to serialize it. It's serial, but not now. Now it's time for me to take a break and go out into the world. And so let's find someone to EXAHost. Who are we going to... I am the only person streaming EXAPUNKS right now. That is not cool. All right. Game dev. Oops, I've been streaming this on game development. Sorry, people. Oh, it's Ludum whatever. Who's doing actual programming? New dungeon system. Why don't all you LD42 people program on normal days? You might get work done. Making my own engine to become rich indie game dev. I don't know. Do you want to watch blocks jumping on each other? Flow Storm session number 7. There's some quaternions. This is some 3D stuff. It's also in Unity. I don't know what looks good. Anyone have an opinion? Let's see those Octonians. There weren't any Octonians here. All right, this is at least some programming. So it's so hard to like paste people's names. All right, we'll probably play some more later. So we'll see you later. Like this evening, maybe.